So we know that dark skies are really important for having a good observing site where you can see the universe in all of its glory. But there are other factors that are also important when choosing an observing location. So let's take a look, just as an example, at the state of California. Of course, dark skies is important, and so that's one of the first things we consider. We'd want to avoid the Los Angeles area in general. We'd probably want to avoid the valley up here, or whatever this is called, the San Francisco area naturally. But there's a lot of dark space in California still. So dark skies we get, that's important. Another thing that's important, naturally, is good weather, right? I mean, if it's cloudy, you can't see the stars, so there's no point in having an observatory there. One way of trying to measure, on average, how cloudy or rainy an area is the amount of rainfall that it receives. So I have here a map of rainfall in California. So this is average rainfall in inches over many decades, right? So this is really a good average. And you can see the green and blues are where there's a lot more rain, and the reds is where there's a lot less. So I'm kind of looking, Southern California looks good, especially southeastern California looks very, very dry in some places. Of course, there's Death Valley over here. We know it's very dry over there. Hardly ever rains in the desert there. Okay, so that's a good thing. It helps us spin down. Maybe even northeast California would work okay because it's fairly dry. All right, so naturally we don't want clouds. That's the second consideration, the weather, clouds. Another consideration is the elevation. That is to say, how high off the ground are you? How many feet, right? Like you think of a topographical map where your mountains are way higher. That's the kind of thing we want to be, up high in the atmosphere. And we want that for several different reasons. Let's look at a map, though, for example, of California. So here's a topographical map of California showing us the elevation. Of course, California has some bona fide mountains in it, so some of these even stretch up to 14,000 feet. So as we look at this, I'm going to say, well, I want to avoid this sort of major valley area in here, right? And I see this is not all that high. You know, this where with not a lot of rain was sort of southeastern California. We're looking at maybe 3,000 feet elevation. Whereas northeastern, we're more at 6,000, 7,000 feet. And of course, we have these mountainous regions right here. So why would we want to be high up? There's a couple main reasons for that. The biggest one, though, is that there's a lot of moisture in the atmosphere, a lot of water vapor in the atmosphere. And that makes our visibility of the sky much poorer, or much worse. The water vapor in the atmosphere does a couple things. One is that it absorbs light that's coming through, and so astronomers can't necessarily see through as much of that water vapor, especially in some of like the infrared parts of the spectrum of light. So when astronomers build observatories, they try to make them in dry places that don't rain and that are high elevation, all to avoid that moisture that's in the air. Okay, so now this is where it starts to get complicated. I want to consider light pollution, I want to consider elevation, and I want to consider rainfall. So let me just look in this southeastern California area. I saw that was a dry area. It's a moderate elevation, not very high, but let's just look at the rain or the light pollution. So here's the southeastern. It's looking pretty good. Looking pretty good. Let's just say I want higher elevations than that, though. I want to be higher up than this. So I'm going to look more in this northern part. In fact, I see this little stretch of red here, this town called Altura. So I want to check that out. Let's look at that in terms of light pollution in northeast California. In fact, I can search on that town. I'm going to search Altura, California. We'll zoom me way in, and I see the light pollution is actually looking pretty good. It's quite dark as long as I actually avoid the town itself. Right here, there's some national forests where it's really quite dark. So I'm liking the light pollution here near Altura. I'm liking that it's relatively dry, so that's good. And I'm liking that it has a relatively high elevation. So I'm finding the combination of things I want to see. So those are three things we've seen: dark skies, good weather, it's dry, and a high elevation to avoid that moisture in the atmosphere. The third thing is a little more abstract. We can illustrate it here with this weather map that I'll show you. So I'm looking in northeast California. I think this will be a good close one here, the Golden State Star Party. So here's what we call the clear sky clock. And this is what a lot of astronomers use. It's made for astronomy to figure out over the next 24 to 36 hours what are the sky conditions going to be like. And so naturally, what do we want? We want it to be dark, and we don't want there to be any clouds. So you'll see the first line here is cloud cover, and the darker blue it is, the less clouds there are. So it's showing me that it's going to be relatively clear over the next 36 hours. Transparency, that's kind of a measure of that moisture in the atmosphere that we were talking about, and that can fluctuate from day to day. And so we see that the transparency, even though there are no clouds, there's still a lot of moisture in the air, and so the transparency is not great, especially in certain parts of the night. And this is the thing I want to mention, this idea of seeing, which is a specific thing in astronomy, which is telling you basically how crisp of an image can you get through the telescope. And that depends a little bit on moisture, but also on how much fluctuation there is in the atmosphere, which can depend on the winds. It can depend on actually like kind of the shape of the land, like if there's big jagged rocks around, it could make the wind fluctuate more. So the seeing is sort of a measure, again, of how crisp the image can be. In fact, when professional astronomers go and look out for new locations, they'll take instruments along, special cameras along, just to measure the seeing, because some places have much better seeing than others. Even within a single observatory, like at Kitt Peak National Observatory in Arizona, some parts of the mountain have better seeing than other parts of the mountain. So they'll put the best telescopes on one part of the mountain and the smaller telescopes on another. Okay, so those are, I would say, 4 things that we look at: the darkness, the elevation, the weather, and the seeing for finding a good location. Now, once we've found a good location, I'm pretty happy with this all around. We can go and use a little latitude longitude finder and actually get the exact latitude and longitude of that location. So this town was called, let's see here, Alturas. So I'm going to search on that, Alturas, California. And of course, I don't want to be in the town for the light, but I want to be a little further out of town, and there were these nice big kind of mountains nearby. Yeah, here's some nice mountains. So let's just say Bald Mountain. That looks like a good spot to go. So I'll click on my map, and you see there's the exact latitude and longitude.